Hello. Today I'm going to show you how easy it is to build a 3D scene in a web browser entirely in JavaScript, leveraging the incredible power of WebGL. This should work in most PCs and laptops built in the last, say, 3 to 4 years. Some tablets and in some phones. It should run in any browser basically that supports WebGL. And that would include Chrome, Firefox, and now that IE 11 supports WebGL, you can also use it in IE. So let's see. 3GS is the JavaScript library I'm going to use, and you can easily add it to your JavaScript pages to spice them up a bit. 3JS is great at abstracting away a lot of the more complicated things that are a pain when working in 3D. It's one of the reasons I like it. It will create the cameras as 3D objects, also called primitives. It'll create the lights, the materials, and lots more for us, and very easily. And then you can make the decision after you create your scene how you want it rendered, whether you want to use WebGL, HTML5 Canvas, or SVG. And I'll show in upcoming screencasts there are additional JavaScript libraries which can add some very cool physics capabilities to 3GS. So let's get started. Now usually I went ahead and typed in the program here. I've got most of it in. And this is a real simple kind of hello world program. We're going to start really simple and go through some of the basics. Usually now you would download the 3JS SDK, which is a zip file containing all that you need, including many examples, and then you would just include a relative link to your 3JS. In fact, you use a minimum version which has all the white space stripped out. But just to make things easy, I just went ahead and I'm pointing directly to the 3JS on the 3js.org website. To speed things up a bit, let's see. So the first thing we'll want to do is create our global objects here. Okay, we need a renderer. Well, let me skip down to the init. So we're going to basically have an init method and an animate method. And to initialize things, let's scroll down here. We'll first create a renderer. We'll go ahead and create a WebGL renderer. The next thing, it's very important to set the width and height of the viewport so that 3JS knows what size it can draw into. And since 3JS runs in the browser, it becomes essentially another item within the browser DOM, so we need to attach it to the DOM. That's what we're doing here. So the renderer itself has a DOM element in it. And after we've set the size of the window in the renderer, we can go ahead and append it to the DOM. The next item we're going to do here, let's see, is create a camera, and we've chosen to create a perspective camera. And let me scroll over here. This perspective camera takes 4 different inputs. This initial number here is the angle of the actual camera angle, the lens angle. So wide angle lens would be even wider than this. Very narrow angle might be 45. So that's that value. The next value is our aspect ratio. When we have a window, in this case the window is almost square. Maybe it's a little bit wider than it is tall. So we have a ratio of width to height. So if it was 4:3, which is the old standard for television, this would be say 4 units for every 3 in the height. We could choose to do a letterbox style or a high def style window if we wanted to. But what we're going to do is we're just going to take whatever the window is sized to and use that aspect ratio. So what we've done here, we've gotten window.inner width and window.inner height. The next 2 items, this is the near plane and the far plane. So we've chosen to have 1,000 units inside our world. And then we're going to go ahead and position the camera at 400 within that world. We're going to go ahead and create a scene. And then after we create a scene, we have to create an object. And in our case, we'll create a cube. And then before we can do that, we have to create a material for our cube so that we can see something. We could just create a flat shaded cube, or, in this case, what I've chosen to do is just use a texture map, a simple texture map that I was able to find on Google Images, a free image on Google Images of a cute beagle. So we'll go ahead and use that. So we went ahead and loaded our texture, and then we applied it to the material. So we've got a material here. So now that we have a material, we have a color and a material for this object. We can go ahead and create the object. And let's see. The next thing we want to do is create the object. And I mentioned earlier, there's plenty of primitives that we can use. In this case, we're going to use a cube, and we're going to use the built-in functions. You can create these yourself by defining the individual polygons that make up the cube, but one of the nice things about Three.js is it provides a lot of these primitives right out of the box. And so here we're just defining the sides, x, y, and z of the cube geometry. And then this geometry is passed into the mesh method. The mesh method is basically used to create any kind of polygonal primitive or shape, not primitive necessarily, but any kind of shape that you want to use in Three.js. So here we've done that. Here we go ahead and we're going to go ahead and add it to an array of cubes, and it'll still come into play later when we go ahead and add more than one, but right now we're just going to add one cube. And here we create an event listener on resize so that we can adjust the inner width, or the width and height of the aspect ratio of the camera that we were setting up here. We need it to understand that the window has changed and when it gets resized. And we also do another set size like we did up here. So these are important if the window is to be able to be moved around. And then finally we have an animate function, and we call request animation frame initially. We can do any kind of repositioning of the object or rotation of the objects in our world. And in our case, we're just going to rotate around the X, Y, and Z axis, rotate the object around its center, and we're going to rotate it by a very small amount here. And then we're just going to call render and pass in scene and camera. So let's go ahead and do that. Let's come over here and just refresh our screen, and you'll see we've got a cube on there, and there's our beagle. Not terribly exciting, but we are rendering a cube and it is rotating around. So you get an idea of what you can do and how easy it is to do. Let's go ahead and make one change here where we increase the number of objects we've got. So I'm going to replace this little bit of code here with this chunk of code, and let's take a look at what we're doing. We've just got 3 different for next loops. We're going to iterate on the X, Y, and Z here, and we're going to create the same cube geometry, but what we're going to do here is position it at a negative 100, and then at 0, and then a positive 100 on both X, Y, and Z. And so we'll be creating quite a few cubes here. So let's go ahead and do that. We'll save that, and we'll go ahead and run again. So you see we've got a lot of cubes going on there. This is really nothing compared to what Three.js can do and the power of WebGL, and actually the power of your hardware on your computer. It's just amazing. It's kind of an untapped resource. I feel we see a lot of video games out there, and people tend to buy video cards to run their video games, but the stock plain vanilla PC, laptop, tablet has quite a bit of power, enough power to do some incredible things. And you can see just using JavaScript in the browser. And as we resize it, you'll see it just automatically continues running, but it knows exactly how to render that because we have that resize function there. Okay, so I think that's about it. Let's see. I hope the screencast has shown you just how easy it is to use 3JS, and I hope you'll go on to experiment yourself with 3D in the browser. I'll continue this series showing some of the very cool things you can do with 3JS, including some fun physics demos, so stay tuned. Thanks.